Hello, this is the Supermileage Systems Enterprise Design Expo 2020 presentation. My name is Jacob Romang. I am a second-year engineering management major, and I am the current COO of Supermileage Systems Enterprise.
I am Zach Radosa. I am a fifth-year mechanical engineering student. I am the team lead for the body chassis sub-team.
I'm Kari Jansen. I am a fourth-year electrical engineering student, and I am the team lead for the electrical sub-team.
And I'm Connor Stark. I am a third-year mechanical engineering student, in addition to the CEO of the team.
And we will be presenting in the order we were just introduced. So first, I'll cover a brief overview of what we're going to be going over. I'm going to go over a brief team introduction as to who Supermileage Systems Enterprise is, 2019-2020 team goals, team projects for the year, and then we're going to go over in-depth specific project work, and then finally a conclusion and future work, and final acknowledgements. So a brief overview of our team is we are a student-run, multidisciplinary organization interested in developing automotive systems and high-proficiency vehicles to promote sustainable transportation. We are a student organization that competes every year at SAE Supermileage competition and just compete to make the overall most fuel-efficient vehicle possible. Last year, we took first place for our design report at this competition for the second year in a row, and 10th place overall out of the 30 total registered teams. And we compete nationally against other top universities at this competition. So here's a breakdown of our team structure. For time's sake, I don't have time to go through the entire breakdown, but this is just how our team is broken up. And for our 2019-2020 goals, organization goals were to improve team-wide timeline management, making sure we're staying on task and on time with all of our project deliverables. 7-week milestone reviews, making sure every 7 weeks that all of our projects were within their scope. And then finally, maintaining knowledge transfer, making sure our senior members got their knowledge transferred down to younger members that are on the team. Vehicle goals were to increase durability of the vehicle, reduce overall weight of the vehicle down to about 120 pounds, approximately a 4% reduction, increase chassis stiffness, because that was a problem at last year's competition, improve driver interface, and then finally improve overall vehicle packaging of components, just to make sure we have a well-rounded look at the vehicle. And then for validation goals, we wanted to increase vehicle dynamic testing to ensure that we weren't having as much component failure at competition, and then finally increase engine testing on the dyno, because we did run into some engine problems at competition last year. So an overview of the 2019-2020 projects of our vehicle. All of these projects listed here are important and critical to getting our vehicle to where it needs to be for competition. Specifically, we're going to be going in depth on the rear subframe project, vehicle position tracking system project, and engine tuning EFI integration project in this presentation. And with that, I'll hand it off to Zach.
So I will be covering a little bit more detail about the rear frame senior design project that I was on. The overview of this project was to design, validate, and eventually integrate a rear subframe. The interfaces to the Briggs & Stratton 206 ACE engine, the rear portion of our unibody design, and also fix problems with chain tensioning as we had at Comp, and also increase compliance decrease compliance of the rear portion of the vehicle. So some goals are to create and maintain that initial chain tension that we had set, increase the rear vehicle stiffness, so that goes back to the overall stiffness of the vehicle. Main goal, maintain or decrease relative allocated mass of the subsystem, again to the 120 pound goal of the overall vehicle, and design and manufacture the sustainable subsystem that goes to the various components listed to your right. So some features and benefits of this project. There are no complex bending of tubes or other components to match the unibody geometry. This just increases manufacturability, and that way we're able to create a part that is more intended design. Having accessible bolted connections. This goes back to the ease of assembly, disassembly, So we're able to get this in and out of the vehicle as quickly as possible if we have failure in any sort, and integrate the snail cam tensioning mechanism, the green component you see there, with the rear axle. And this allows for incremental centerline adjustment of 15 millimeters. So there should give us enough range here to complete a full run and maintain our tension. So as you can see, we increase the mass very slightly, and this allows for some optimization metrics to be completed and eventually carbon fiber be integrated into this design. And then we had a worst case deflection of 1.62 millimeters and a stress of 190 megapascals. So we have a factor of safety in our strength of material of 3. And Kari will be talking about the vehicle position tracking senior design.
Oh, I'm Kari Jansen, as he said, and my senior design project was a vehicle position tracking system. The overview of this project is that we want to integrate a position tracking system with our current heads-up display and driver controls systems, and improve our accuracy for our lap count and lap position data to enable the driver to implement a more effective burn and coast driving strategy. This ties into our overall goal of improving our vehicle interfaces and driver interfaces. The specific goals with this project were to calculate and display lap position, lap count, and distance traveled using the data from a GPS tracking device to be accurate within 6 feet. And this data would be recorded to an SD card for later analysis and competition run records. The accomplishments to date with this project include a completed hardware design that has been integrated with some of the other vehicle systems, initial systems testing with the heads-up display, which you can see in the below image, and future work to be completed with this project involve integrating it with the full vehicle electrical system and to test it in the vehicle while doing a test run of the overall vehicle systems. And Connor will take over now.
Hi, I'm Connor, and I'm going to do a quick summary of the fuel tuning and fuel injection system. Problem statement, in-car engine testing is not available to us at all times throughout the year, and so we need a dyno that inside a building that shoots the exhaust outside so we can tune our engine with lots of time. Goals, simulate competition engine conditions as much as possible, and while doing this, we can tune the engine for minimum fuel consumption. This reduces torque as a result. That's okay. Our engine is overpowered, and this is actually a good thing. And then in addition, we tune to quick engine startups, which also reduce fuel consumption. Some setbacks overcome include lots of members were unfamiliar with this dyno setup by previous Supermileage teams. And then we had multiple engine dyno failures along the way. So the results of this project is the electronic fuel injection system was installed. In addition, the tuning through EcoCal, the computer software was learned, and torque curves were created. One shown is on the right. And then future work includes installing the engine in the car. It is currently off of the dyno, but it needs to be installed in the car. And then minor in-car engine tune adjustments because these conditions are close between the engine and the dyno, but not completely the same. And then at the end, we need to validate this setup. Conclusion and future teamwork. Our competition this year will be virtual due to the COVID-19 outbreak. All we know so far is we've submitted a design report and we have yet to learn more. Focusing on team-wide documentation is important with lots of time away from project work. And then the fall 2020 semester includes final vehicle assembly and then 3 additional senior designs, which include the engine dyno acquisition system, the chassis dyno, and the reduced displacement and high compression engines. We'd like to thank the following people. On the right is all our major company sponsors. We'd like to thank our advisor, Rick Berkey, Great Lakes Sound and Vibe, Clayton Bethke, and Conley and Patricia Jansen. And again, thanks for watching. I hope you enjoyed this video.